let's keep this train moving. We'll go from heavy metal to something a little lighter. Airstream process 50 times faster than 3D printing. From Europe's foundry and fibionics. This has something to do with some kind of textile, so I was interested to see what they had to say.
We create and produce lightweight products inspired by nature. Every time you need to move a part, lightweighting plays a very powerful role. Automotive, aerospace, in the UAV sector, in the robotics sector. The main issue at the moment is that traditional manufacturing processes are either too slow, too cost intensive, are too wasteful, and this is exactly what we are trying to solve.
We have developed a fully automated production process to produce bionically optimized reinforcement structures.
So from fiber placement, securing fiber position, to consolidation.
Well, they got something secret back in there. Of course, that's probably patented and they're not wanting to share just yet.
It's all integrated in one machine.
Saving as much resources as possible and then providing these advantages to the mass markets.
Almost any hardware product would benefit from lightweight design and the usage of lightweight materials. But current production technologies are manual labor intense and they waste a lot of this precious reinforcement material. And therefore, composites are often too expensive to use it in daily products. That's exactly where Fibionic comes into.
Well, I don't know how much of it is the waste and how much of it is just carbon fiber is complex and expensive to make flat out. On the other hand, there's very few places that are actually making it too, so that could be something that's more readily fixed.
Place.
We always have a look at nature, how it's designing things. In nature, only the fittest survive, so only the most or the best structures survive by the end of the day. Nature had about billions of years to just like develop the ideal structures.
Minimum resource consumption to reach exactly the properties that are needed for a component, for a body part. Humans often tend to over-engineering. So that's why we said, let's go a step back, oriented nature, use materials only exactly where needed and nowhere else.
What we have seen before is,
on the other hand, there is something to be said about over-engineering as well.
that companies are placing single fibers every roving after each other by a gantry system, which is rather slow.
So we at Fibionic, we tried to change this thought and oriented on other production technologies. We found out, let's have a tool-based production process for high volumes.
We build a tool with channels, so we input these fibers into the tool, and with an airstream, we just shoot it into these channels and then take it out and position it, making it much faster than ever before.
We are fully optimized from creel, from roving to the finished product. So we start with the creels, with our input material, which are commingled yarns, consisting of reinforcement fiber and also thermoplastic matrix material.
So you can imagine that now.
So it'd be carbon fiber mixed with, could be nylon, could be any of the 3D printing polymers. Probably not PLA, but probably something like PETG, PET, polycarbonate, PCTG. There's a broad range of what you can be using.
Like the fibers are just like fed up into our machine, and then it actually looks like this. A special gripper system takes it out of the mold and then position it and keeps like the real fiber angles inside a plate.
By using temperature and heat, we finally consolidate our inlay and receive the final mechanical properties.
Now you have the 3D fiber skeleton. One is just put inside the injection molding machine. The machine closes, injects the plastic, and out comes the finished part. So overall, we have a cycle time of about 1 minute, like the part production and also the injection molding. And I think this is like world record for making this high-level composite material. People are asking, how do you know where to place the fibers? So within our software suite, we are having optimization algorithms, which are inspired by natural design principles, where we are aligning the fibers along the load path within the structure.
So this is exactly the digital twin of our series production product, like the one we showed you before. So this product is exactly what we can see here on the right-hand side.
Thomas is one of our co-founders, and he studied composite technology. And within his PhD thesis, he developed completely new algorithms to calculate load path optimized structures. Within this theoretically and digital world, he found out how huge the benefits and how huge the impact of this design approach can be.
I did a lot of finite element modeling and found out that there is like a nature-inspired way how to do it, like placing fibers along the load path.
And he came up with this bionic design approach, placing reinforcement fibers only where necessary.
Saving a lot of material and saving therefore also a lot of cost and also weight.
By the end of my PhD, I came out and said, yoo-hoo, I can do marvelous things in the digital world, but actually when I want to manufacture it for like hundreds of thousands of parts, there is like this big gap.
Looking into the real world, at that time there was no production technology available to really produce bionic reinforcement structures. There are even some customers waiting for it, but there's no possibility to produce this kind of structures in high volume.
We teamed up and said, there is this digital wonderful thing we can do. So let's think about how we bring it into the mass fabrication. And we sat together, just like made up our brain, our mind, and found what we're doing now. So just shooting fibers into a tool with channels.
I wonder if they're actually
hand-built. What's missing is her story. For decades,
I wonder if they're actually gonna show how this works, or if they're just gonna gab about it. Oh, look at this thing, what we can do, but we're gonna show you what it is.
taught to fear the future, not build it. That's why we are making documentaries about the engineers, scientists, and founders building the future here in Europe.
We have many things that just like help sustainability. Bionic design uses much less fibers than any other technology. During our production, we have very little waste material, which is also helpful for sustainability. And then parts are lighter, so during the use, they consume a lot less CO2, for example, as well.
Yeah, of course, it always comes to CO2 these days. How about looking at fuel efficiency or energy efficiency? Extending the lifetime and range of your product instead of focusing on something that's so insubstantial yet overhyped.
And our parts are also recyclable. So at the end of product's life, it is possible to just use these structures again, to shred them down, to recycle them mechanically, and just produce this kind of pellets or granulates, which can be used in injection molding, and they can even go to the same product again. We are using carbon fibers, and they are like commingled, or they're hybrid fibers with thermoplastic fibers. But we are also going towards natural fibers, like for example hemp fibers. We can go towards glass fibers or aramid fibers or any kind of...
And aramid is Kevlar or Spectra, that kind of class of fiber.
Reinforcement fibers you actually want to use. The materials we are using are actually co-developed with our suppliers, so there was a lot of work also just like finding the right material setup. We are using about 55 volume% of carbon fibers, which is quite all right. We can go up to 60%, but just finding out the right recipes for our specific process was challenging. We had to develop much more than we expected, because like everything you get on the market was just like too expensive for a startup. So we really had to go to the scratch.
Yeah, that's unfortunately the way things go. Nobody wants to give money to a startup unless you got something spectacular, and even then it's iffy.
Think all the process steps and just do them by ourselves. So also, like as I explained, like we also patented the consolidation process. That's not because we wanted to, that's because we had to, and to find a more or less not that costly solution. One of the big challenges with our technology is that you don't have to do like a single process step. What you need to do is building a whole ecosystem. So you have to provide software to tell people how they design their product. You need to go for prototyping with country systems. You need to think about the forming, and then you also need to think about the series production. So we are building a full ecosystem consisting of software, hardware, and also material. And I think this is the really challenging point. So it's so much work to do. We did this with about 5 people, and I think this is really underestimated. So
It's actually probably the best way to do things. Have as few people working on it as possible, because if you get too many people working on it, one, you're going to burn through your budget in a hurry, because payroll is a bitch, and well, people get kind of upset when they don't get a paycheck. And two, you don't get overlapping and over-conflicting opinions on stuff. Keep your team as small as necessary, or as big as necessary. Don't go adding more people and thinking, oh, I've got a great company because I have 100 engineers working with me. No, 5 is a good start. Preferably 5, and each one has their own specialty.
you model it in our software, and then you get like the manufacturing recipes for our gantry system or for our series production.
I'm thinking it's supposed to be gantry system that he's talking about. Autodub is auto-corrupt.
Machinery out of this software. So it's an important point to scale and to bring the technology to the people and not design every part just by ourselves, which is important just to produce these parts in like the big numbers.
We are growing so fast, we are trying to expand, and we actually need to expand our space. That's why we now have our second office here, where some of our employees are located.
Everything worked out pretty well, and then starting this fiber inject machine, making thousands of parts. And I think this is now also a point where you see this is scalable, this is industrializable, and this is actually the point where you see that it can work. As we see here, we can even play around with our technology.
Those are some pretty complex shapes that they're running.
We just like have new employees, and they tried like some different kind of fiber trajectories just on their own, and that's pretty easy with our prototyping hardware systems. Innovation only comes from innovative companies, and I think there is nothing more innovative than a startup. Just like bringing some very motivated people together and then living their idea and living their dream. I think nothing just like has more power than that. I think in Europe it would be good to have more startups to just like drive innovation, to go for new challenges, and just like also to empower young people.
Europe actually has great talent, great research, especially basic research, but I think it mainly lacks from the way out of university to using it in business, for example. And I think this is one of the biggest mistakes Europeans are doing. I think they stop when it really gets interesting.
Sometimes people come to us and ask us, you are...
I wonder how much of that is culture and how much of that is government red tape getting in the way. Because the EU is particularly horrible for absolutely stupid laws.
Are another 3D printing company, and that's actually totally wrong. We are creating a totally new approach of how composites are produced, being much faster than any kind of 3D printing technology, as we are applying an airstream process that allows us to position one fiber layer in just milliseconds.
Our goal is that everyone by the end of the day thinks about our technology and uses it in their parts, because we want to make parts lighter, we want to use less material in these parts, and therefore change also like the ecological footprint of these parts.
Our mission is to make lightweighting affordable and sustainable establish a new production standard for the production of lightweight composites.
Well, that was interesting concept, a little bit disappointing we don't actually get to see the process. Maybe something will come out later on.